Hello guys, and welcome to the another video of data structures using Java. In this video we will be solving a problem called as merge to sorted linked list. So what basically the question says that we will be given a two linked list and both the linked lists are sorted. If you observe carefully, 5, 6, 6, 8, 9, this linked list is completely sorted, and another linked list 1, 2, 4, 5, 7, 8, 10, this linked list is also completely sorted. And what does the question says that we need to combine both the linked list, and whatever the combinations we get, that combination is also need to be sorted. So I hope you understood the meaning of the question. Simply we need to combine both the linked list together to obtain a new linked list, but at the same time the new linked list should contains all the elements of first linked list and all the elements of second linked list, and the new linked list should be completely sorted. Okay, so let's try to first solve this problems using the brute force solution. So what does the first solution that comes in your mind? What we can say that we can simply keep a two pointer, that is temp1 that is initially pointing to the head 1 and the temp2 which is initially pointing to the head 2, and what we will do is we will traverse the whole linked list of first head and we will traverse the whole linked list of the second head. We will store them into an array, then we will sort the array, and what we will do is then we will construct the new linked list of the sorted array, right? So let's suppose I am maintaining the new array called as ARR, and what I will do is first traverse the whole linked list. That is, first take 5, then move to the next node, take 6, move to the next node, again take 6, move to the next node, again take 8, move to the next node, again take 9, and simply move to the next. So you finally ended up null. So you have completely traversed the first linked list. Do the same thing for the linked list 2. They would the same thing for the linked list 2. So again I will take 1, move to the next node, take 2, move to the next node, take 4, take 5, take 7, take 8, take 10, and again you finally ended up at null, which means you have completely traversed the second list as well. So these are the elements which you got in the array. Now what we can simply do is we can simply sort the array. After sorting, how does it look like? We will get simply 1, 2, 4, 5, 6, 6, 7, 8, 8, 9 and 10. So this is what a sorted array will look like. And finally what we can do is for every element in your array, you can construct a new node and simply return the head of the newly created linked list, right? You can simply return the newly created linked list. So if you try to write the pseudocode for this, how it look like? What we can do is we can simply maintain the array called as ARR, or you can also maintain the array list. Then what we can do is I have kept the pointer temp1 which is pointing to the head 1. So keep on traversing the temp1 till it is not reaching to null, and simply inside your array add the data of the temp1 dot data. You can simply add the data and move ahead. Let the temp1 go to the next node. Similarly do it for the temp2, that is, take a new pointer called as a temp2 which is initially pointing to the head 2, and keep on doing this till your temp2 is not equals to null, and simply push the data of temp2 into your array list, that is temp2 dot data, and simply move your temp2 to the next node by temp2 dot next. So in this way what you have done is you have simply inserted all the elements present in your linked list into the separate array, and now what we need to do is we need to simply sort the array. And once you have sorted the array, build the new linked list for the elements present in your array. So simply build the new linked list, right? Return build new linked list and simply pass array in it, which means whatever the elements present in your array, for every node create the new node, for every element present in your array create the new node and simply return. And what does this function will return? It will return the new head. So this is the brute force solution which you can use to merge the two sorted linked lists together. So what will be the total time complexity for this? So for this it will be big of n time, because we are traversing the whole linked list, and for this it would be big of m time because it might contain the nodes which can be less than or greater than the first linked list. And again we are sorting it. So if you are sorting it, what will be the total time complexity? It would be n plus m log n plus em, right? We are sorting all the linked list present in your first list and the second list. We are sorting all the list nodes, right? So that is the reason why n plus m. And finally again we are building the new linked list for every single node. So again this will take big of n time, this will take big of n time. Therefore total time complexity would be big of n plus big of m plus big of n plus m log n plus m plus big of n. So this would be my time complexity, and space complexity would be big of n plus m, because you are using an extra array, plus you will be building a new linked list of the total number of nodes. You are building the new linked list of all the nodes present in your both the linked list. So this is the brute force solution you can use to merge the two sorted linked list. Now let's move on to the next solution, that is how we can optimize the solution to merge the two sorted linked list. So if you observe carefully that both the lists are completely sorted, right? Both the lists are completely sorted, and we are going to take advantage of it. We don't need to create an extra array, we don't need to sort the array, we even don't need to build the new array, we don't even need to build the new linked list itself, because both the linked lists are already sorted. Then why should we build a new linked list of the sorted nodes? Why can't we simply make use of the nodes which is already present? For example, 1 is pointing to 2, 2 is pointing to 4, 4 will be point to 5, 5 will point to 6, 4 will point to 5, 5 will again point to 5, it will point to 6, it will point to a 6, it will point to 7, 8, this will point to this, it will point to 9, and it will simply point to 10, which means both the linked lists are already sorted. So we can make use of these nodes. So now let's check how we can make use of the sorted linked list to merge them together inside the new linked list, that is sorted linked list. So here we will be using a new concept called as a dummy node linked list. What is a dummy node in the linked list? Simply says that, so as of now simply consider this is the node which is dummy, which is of no use for us, but for the sake of merging the linked list together we are keeping it. So as of now it contains a 1 and it is pointing to a null, So what I will do is I will keep again two pointers, that is temp1 which is pointing toward head 1 and temp2 which is pointing to the head 2. Now I will observe carefully that both the linked lists are sorted, So I have 5 at T1, I have 1 at T2. So which one is the smaller? Of course the element present at T2 is smaller. Now what I will do is I will simply take the whole node this. I will going to take the whole node. See, I am not creating the new node. I am simply taking this whole node itself. So what I will do is to the next of dummy node I will simply put the 1 over here. Sorry, not -1. I will put 1 over here, and what I will do is I will simply move to temp to the next, temp2 to the next node, and simply I also have the temp which is initially was pointing to the dummy node, and now what I will do is I will simply take temp to the next node itself. Now again I have temp1 and temp2. Now which one is smaller? 5 is smaller or 2 is smaller? Of course 2 is smaller. So simply I will take the node that is 2 and I will keep the 2. I will move the temp to the next position, and I will also move T2 to the next position. Now I have 5 and I have 4. Of course 4 is smaller, so simply take 4, right, and take my temp to the next position and also move my temp 2. Now observe carefully that T1 is 5, T2 is also 5. Which one you can take? You can take any one, right, because both the values are same. So let's suppose I am taking the value present at T1. So simply I took 5, I moved my temp to the next position, and I moved my temp 1 to the next node. Now I have 6 and I have 5. Which one is smaller? Of course 5 is smaller. So simply I will take 5, I will move this temp to the next node, and also at the same time I will move the position of temp 2 as well. Now this is the 7 and this is the 6. Which one is smaller? Of course 6 is smaller. So simply take 6, move my temp to the next position, and also move this temp T1 to the next node. So again I have 6, I have 7. Of course 6 is smaller. So again take 6, move the temp to the next location, and also move the T1 to the next location. Now I have 8, I have 7. Which one is smaller? Of course 7 is smaller, right? So let's write over here. So I have 7 and move my temp to the next location, and I will move this temp to over here. Now both are 8. Which one is smaller? You can take any one. Let's suppose we will take T1. So I will simply create the new node called as 8, move this temp to the next node, and I will simply move this T1 over here. Now I have 9, I have 8. Which one is smaller? Of course 8 is smaller. So simply take 8 once again, move this temp to the next location, this move to this. Now which one is smaller, 9 and 10? Of course 9 is smaller, so simply take 9, move this temp to the next location, and now my T1 is at null. My T1 is at null, which means the linked list first, that is first linked list is completely traversed. First linked list is completely traversed, and there are some elements left in second linked list. Now do I need to traverse the remaining second linked list? No, because already these elements are sorted. So simply what I will do is, wherever the temp2 is pointing, I will simply attach that node. Wherever the temp2 is pointing, I will simply attach that node, because all the elements to the right of 10, is also sorted. So we don't need to go to every single node to the right of the 10, because they are already sorted. So simply I am going to attach this 10 to the 9. I don't need to traverse or check every single node of the remaining list, Similarly, there might be a case that my linked list 2 is completely traversed and there are some nodes in linked list 1 are still present. Then what we can do is, we can simply attach the remaining nodes to the end. We don't need to check every single remaining node, because they are already sorted, right? And now observe carefully that which is my new head. This is my dummy node, and my linked list is starting from 1. So can I say that my new head is nothing but dummy dot next, which is nothing but this is my new head. So simply I can return a dummy dot next. So I hope you at least got some idea about how we can approach this problem. Now let's go and write some pseudocode to get a more clear idea on this problem. So what basically I did is, I simply kept T1, which is pointing to a head 1, and there is one more pointer called as a T2, which is initially pointing to the head 2. And what I did is, I simply created the dummy node, right? That is new node, which is initially contains -1. And what I did is, I simply kept the temp as well, which is initially pointing to dummy as well. Now I need to keep on doing this. While my temp1 is not equals to null, right? And temp2 is not equals to null. Until unless I don't come up or end up any one of the list, I have to keep on going. Right? So what I will do is, inside this I will check which data is smaller. Is the data present at T1 is smaller, or the data present at T2 is smaller? So what I can do is, I can simply write if T1 dot data is less than or equal to T2 dot data, then what we can do is, I can simply write here as temp is equal to, I can simply write it as temp dot next is nothing but T1. I can simply move the temp to the next point, that is temp is equal to temp dot next, and I also need to move my T1 equals to T1 dot next. Similarly, if this is not the case, which means the element present at T2 is smaller, so we can do this. How we can do this? Simply we can do this temp dot next equals to T2 and temp equals to temp dot next, because we have to move this pointer to the next, and I can simply move T2 equals to T2 dot next. So this is the simple case. Now there might be a case where you can either end up with first linked list and there are some elements present in my second linked list, or you are completely done with the second list and there are some nodes are present in your first list as well. So what basically we can do is, we can simply check if your T1 is not equals to null. If T1 is not equals to null, I can simply do temp dot next equals to T1, or if this is not the case, if T2 is not equals to null, I can simply do temp dot next is nothing but T2, and finally I can return what? Dummy dot next, because this is our new head, because this is the dummy node which we have created, and this node is of no use because in both the linked list there was no any -1 present, right? So this was the small code or the small approach we can use to merge the two sorted linked lists together. So now let's go on to the IDE and try to check how we can submit this problem. So here is a code that I wrote, whatever we discussed on the iPad. So first of all, as the base condition I use, that is if the head 1 is null, which means the first list is empty, we don't need to do anything, simply return the second list. Similarly, if my second list is empty, I don't need to do anything, simply return the first list. right? And then I simply created the dummy node which contains a value as -1, and then I kept as a new head is equal to dummy node, and then I kept the 2 pointers, that is temp1 and temp2, whatever we discussed in the on the iPad, and kept on doing this until unless both are not equal to null. Inside this I simply checked which value is smaller, either temp1 or temp2. If any one of them is smaller, I simply inserted dummy node dot next equals to temp1, and then I simply took temp1 equals to temp dot next. Similarly, I done for this temp2, and I moved the dummy node equal to dummy node dot next. And finally, if any one of the node list is not completed, simply attach it to our dummy node and simply return the new head dot next. On the iPad, we simply return we use instead of new head, we use the temp, and here I use the new head, and we simply return the dummy node dot next. So this was a small change I made. So I hope you understood this question clearly and properly. Just in case if you are new to our channel, do subscribe the channel for more such informative videos. Till then, see you in the next video.